Okay, so we're going to look at factoring by the style of decomposition. Okay, and the first step to factoring, well, first all we need to do is label all of our coefficients. We factor when we're in standard form. Okay, so if you remember standard form, it's usually written like this: f at x equal to ax squared plus bx plus c. So there's an a here, there's a positive b here, and then a c at the end. And we have to be able to label which of these are which in order to organize what we're doing. So our c term is 40, our b term is 10, and our a term is -5. And the goal of this is to get the factored form.
AX, yeah. You can print this on here, yeah.
Okay, so what we're going to do from here is a great step might be to common factor, but we actually don't have to common factor.
Yeah.
Okay, we can actually factor from the style. So we're just going to focus on the factoring itself. We need two numbers, okay? And those two numbers are going to need to multiply to our a term times our c term. Okay, and those same two numbers are going to have to, are going to need to add, where's my undo? Oh, there it is, to our b term. Okay, so this is pretty easy. Our b term, we can look and see what it is. It's positive 10. So I need two numbers that add to positive 10. But I also need two numbers that multiply to, and what is a times c? So maybe we should bring up a calculator here to see what our a times c is. A is -5. So, no, can't do it in that order. Let's -5 times positive 40 equals -200. Okay, so we need two numbers that multiply to -200. So one thing I can start doing is trying out factors of 200. Well, there's 1 in -200. Because it's a negative, one of these will have to be negative, but 1 in -200 definitely don't get me to 10. Right? There's 2 in 100, but 2 in 100, even if one of them is negative or the other is negative, they still don't get to 10. Okay. 3 doesn't go in. 4 goes in. 4 goes in 50 times. Again, there's no combination of 4 and 50. Whoops. But there's a number I can think of really quickly. I know 10 goes in. And 10 times 20 gives me 200. Yeah. And 10 times 20, if I add them, it'll be 30. But I know one of them's got to be negative. So let's write these in. 10 and 20. Okay. And 10 and 20. How can I manipulate this to make this positive 10? Which of these do I need to make negative? Do you know?
You'd make the 20 negative.
If I make the 20 negative, it'll make this negative 10.
Yeah, so the 10 negative.
Great. So we make the 10 negative and then 20 positive. So we put it up here, and that works fine. Negative 10 times positive 20 is -200. So that's great. So what we've just done is we found what we're going to decompose this.
That equals -200? Those two? Okay.
Yeah.
Because the negative, positive, the negative. Oh, yeah.
Yeah, that's right. So the next step here, and I'm just going to rewrite this equation to start out, is we're going to decompose the b term. And what we mean by that is we're going to split it up. So the idea is if I have the number 5, I can technically rewrite 5 as something like 8 minus 3. It's technically the exact same thing because 8 minus 3 simplifies to 5. But we're doing this to help us with our factoring. So they usually draw two arrows from the b term. And the way you'd rewrite this is h at t is equal to -5t squared. And then we just write them in either order, -10, and we have to attach the t, plus 20t. That works out fine. And then our positive 40. Okay. The reason we've done this is because now we're going to decompose the first pair, common factor the first pair, and common factor the second pair. So I got to find a common factor. Well, I know -5 will come out of both of these coefficients.
Oh, you'll find a common factor. So that's the step I was at right here.
And then we also factor out that t term. So let's watch.
Oh, that's the step I forgot.
So we take out -5t, and that leaves us with t plus 2. Okay, and in the other one, I can factor out the number 20. Okay, so I common factor out 20. So it's positive 20, what I took out, and then what's left in the brackets is t plus 2. So now in this situation, what's happened is I've now broken this up so these two need to be the same, and that's the whole point of this decomposition. I have to make sure these brackets are the same. When they're the same, what's actually happening here is we're common factoring them out, but a quick way to remember how to do that is we just take these two brackets and we write it as 1 here, t plus 2, And the other bracket is
Use
just the
negative 5t plus 20.
exactly negative
You make
5t
rings bells again.
plus 20. And then that's it. That is our factor form. I'm going to rewrite it all in black here so it looks like a final answer. So our final answer is t plus 2 in the bracket negative 5t plus 20. Now, I want to take this a little farther because the goal here, let's say I want to find out the x-intercepts. So when we're in factor form, an x-intercept is when the y value is 0. So if I have a kind of a graph like this, and I have something like this is an x-intercept, okay? And this is when...
Oh, because it only goes on the x-axis, so y doesn't...
So our y value is 0 here. What that means is we're going to turn this h at t into 0. So we're going to say 0 is equal to t plus 2 times negative 5t plus 20. Now the goal here is to multiply two terms, and we don't know what the terms are, to equal 0. Well, there's only one number you can multiply by to get 0, and that's the number 0 itself. So we go in the assumption that one of these is 0. In order to solve it, we split this equation up. We set 0 equal to t plus 2, and we set 0 equal to negative 5t plus 20, and then we isolate for t. When I bring 2 over, it becomes negative 2, so negative 2 is equal to t. Here, I bring 20 over, I get negative 20 equals negative 5t. My t is not by itself yet, I'm going to have to divide both sides by negative 5. Okay? And what that leaves me with is t is equal to, and this number is 4. So what I just found are my two x-intercepts. My x-intercepts and my rough drawing, oh, that's the wrong.
So that is the step that you do after the...
After the factoring itself. So what we have here is negative 2 and 4. And let's just say, and we didn't really talk about it, but let's just say this was modeling someone standing on a cliff. So there's some happy guy here, right? He's standing on a cliff and he threw a ball down the cliff. And we want to know, and maybe our x is time, and this is the height of the ball. We want to know at what time did it hit the ground. Well, we actually have two answers, negative 2 and 4, except with time we never, or it doesn't tactically make sense to say to go back in time 2 seconds. We wouldn't say 2 seconds before we threw the ball it hit the ground, because it didn't. It hadn't been thrown yet. The throw starts at 0, and then at 4 seconds it hits the ground. So at 4 seconds, our ball has hit the ground. This is our logical answer. This one is kind of illogical because we were standing on a cliff, and we didn't throw it down from there.